The Internet, as we know it, faces a foundational challenge as artificial intelligence agents increasingly interact with its vast expanse. Originally designed for human perception and manual input, the web presents a labyrinth of visual interfaces, buttons, and forms that AI agents struggle to comprehend deterministically. This fundamental mismatch introduces significant operational hurdles for advanced AI systems. Today, when an AI agent attempts to complete a task on a website, it often resorts to methods akin to screen scraping. This involves parsing raw HTML, inspecting accessibility trees, analyzing rendered pages via screenshots, and then inferring which elements to click or fill. This approach is inherently brittle, slow, and computationally expensive. A minor alteration in a website's design can disrupt an entire automated workflow, leading to frequent failures and a cumbersome user experience. To address this inefficiency, Google and Microsoft, in collaboration with the World Wide Web Consortium, have co-developed the Web Model Context Protocol, or WebMCP. This emerging browser-native standard introduces a structured mechanism for websites to explicitly declare their functional capabilities to AI agents, moving beyond heuristic guesswork. WebMCP fundamentally redefines how machines interpret web content. Instead of AI agents attempting to reverse engineer a human-centric user interface, WebMCP provides a parallel, machine-readable layer. This layer exposes a defined tool contract, which is a manifest of the website's interactive functions. At its core, WebMCP allows web developers to register these specific functionalities as tools. Each tool is essentially a JavaScript function accompanied by a clear name, a descriptive explanation, and a structured schema outlining its required input parameters and expected output format. Examples include search products or add to cart. The browser then exposes these structured tools directly to AI agents through a new native API, navigator.modelContext. This eliminates the need for agents to guess button purposes or form fields, enabling direct invocation of a website's capabilities within the user's current browsing session. Developers can implement WebMCP using two primary paths. The declarative API offers a straightforward, HTML-based approach. By adding specific attributes like toolname and tool description to existing HTML form elements, websites can make simple, static interactions, such as form submissions or filtering, directly callable by AI agents without requiring complex JavaScript. For more dynamic and complex interactions, the imperative API provides a JavaScript-based solution. This path utilizes navigator.modelContext.registerTool to expose client-side JavaScript functions, allowing for multi-step workflows like booking systems, checkout processes, or real-time availability checks, complete with explicit JSON schemas for input and output validation. This dual-layer architecture creates a robust system where the human visible web interface remains unchanged for traditional users, while a precisely defined, programmable interface becomes available for AI agents. This separation ensures reliability for machines while preserving the rich, human-centered design for users. The adoption of WebMCP translates into significant operational advantages. It dramatically enhances the reliability of AI agent interactions by eliminating the fragile guesswork of screen scraping. Furthermore, it improves efficiency, with early benchmarks showing up to an 89% reduction in computational overhead and token usage compared to vision-based methods. This leads to faster task completion and higher accuracy, reaching approximately 98% for complex operations. Beyond technical efficiency, WebMCP introduces a new dimension of web optimization, Agent Experience Optimization, or AXO. Websites that implement WebMCP are more likely to be prioritized by AI agents acting on behalf of users, as these agents can reliably understand and transact on such sites. This will drive AI-referred traffic and conversions, fundamentally shifting how organic visibility is achieved in an agentic web. In practical terms, this means users interacting with AI assistants like Gemini or ChatGPT could effortlessly complete complex tasks. An AI agent could book a flight, add specific items to a shopping cart, or file a support ticket by directly invoking website tools, all while operating within the user's active browser session and respecting existing security and privacy boundaries, including user consent for sensitive actions. It is crucial to distinguish WebMCP from the traditional Model Context Protocol. While both facilitate agent interaction, traditional MCP is a server-side protocol connecting agents to backend APIs and databases. WebMCP, conversely, operates client-side within the browser, inheriting session state and authentication, making them complementary rather than competing standards. As AI agents become ubiquitous in how users interact with the Internet, websites without WebMCP support risk becoming effectively invisible to these increasingly influential intermediaries. Therefore, the implementation of WebMCP is not merely an enhancement, it is rapidly becoming a fundamental necessity for any website seeking to remain discoverable, usable, and actionable in the evolving agent-driven web ecosystem.